Welcome back to another homework help. This is Unit 4, Lesson 2. Here we are at question 1. Today we were introduced to a balance or keeping a hanger in balance. A couple of things to remember that when we're talking about balanced means that this expression here on the left is equal to the expression here on the right. You might be saying an expression. Well, yeah, an expression is symbolic representation of a quantity. In this case, I know that 1 square plus 1 triangle is equal to 2 circles and 1 triangle. Some other things that I should pay attention to before I do this is recognizing a couple of other characteristics here. I see that there's 1 triangle here and 1 triangle here. I'm being told that this is in balance, this is equal. By that understanding, it should tell me that 2 circles are equal to 1 square. So these two right here are equal. These two right here have an equal value. Knowing that will help me with the next set of information here. So the question it's asking, which of the changes would keep the hanger in balance? Select all that apply. Option A, adding 2 circles on the left. Let's go ahead and do that. We'll go ahead and go and add 1, 2 on the left. And then on the right, it says adding 1 square. Well, as we established earlier, we know that 2 circles is equal to 1 square. So I've added the same amount of weight to each side. This tells me that my scale or my hanger is balanced. Another thing that I can look at is this. I see 1 triangle on each side, here and here. I see 2 circles here and here. And then I see 1 square on each side. We see that we have the exact same shapes on both sides. So we know that on option A, this one would maintain balance or maintain equality between the two expressions. Okay, so A is good. What about B? If I just add 2 triangles on each side, does that also maintain balance? If I add 1 here and I add 1 here, that's adding the exact same quantity on each expression. I want to go ahead and add the second one to each side. And we continue to see that I'm adding the same value, 3 triangles on the left, 3 triangles on the right. And knowing that the square and 2 circles are also equal, I'm still equal. Letter B is balanced. I want you to try out C, D, and E. There is one of those, C, D, and E, that is correct. The other 2 are incorrect. So you have A, you have B. Figure out which one it is, C, D, or E. That would be the correct answer. Question number 2 is again looking at another balance. Here's a balance hanger diagram. And in this case, we have just a little bit more that we're looking at. First thing that we want to check out is let's see what it actually represents. I see that I have several blue squares. I see that I have 4 on the left, 2 on the right, 2 triangles on the left, 1 triangle on the right, 2 circles on the left, 3 circles on the right. And I know that this hanger is balanced as it is. Okay, so each triangle weighs 2.5 pounds. I'm looking right down here. Each triangle weighs 2.5 pounds. Each circle weighs 3 pounds, and X represents the weight of each square. Select all the equations that represent the hanger. What I would suggest on this one is just look at your problems and label it. Triangles are 2 5/10, 2 5/10, 2 5/10. And label all of the triangles. Go ahead and label each of the circles. 3, 3, 3, 3 here, 3 here. And then X represents the weight of each square. So here's an X, and X, and X, and X, X, X. And assume that all of these are addition. That's what we're working with right now, that we're just combining all these together. So what do you see here? Thinking about combining these into groups, I can't combine my triangles with the squares because they're not like terms. They're not the same value. And I know that because the triangles have a value of 2.5. I know that the squares have an unknown value, but I do know that the circles have a value. Understanding that the triangles and the circles have a known value, I can get a combined total of this section is 3 plus 3 and 2.5 plus 2.5. So this is 5 plus 6. This section right here weighs 11 pounds. And this section right here weighs 3 plus 3 plus 3 is 9, plus 2.5 is 11.5. I know that those values can be added together because they are known values, but I can't add them up with the x's because I don't know their value. We have to look at x as a little bit different situation. If you remember from the work that we did, this is 2 of x, and this one over here is 4 of x. Now, if I look at my situations down below, I can start thinking about these pieces and saying which of these situations down here below represent this diagram of the hanger. On part A, I see an x plus an x plus an x plus an x. That's 4 x's plus 11. Well, that represents the expression that I have kind of going on right here. And on the right, I have a single x plus 11.5. Well, that single x doesn't match with that first part of the expression, so A is out. B, 2 times x is equal to 5/10. Well, I have to think about this for a minute. Is it possible for me to get 2x on the left, basically eliminating, I'm going to go ahead and clear this out. We know this one's gone. Is it possible for me to get 2x? Well, I know that the blue boxes are x's. So 2x, if I eliminate 2 x's from here, I would have to eliminate 2 x's from here. Remember that the box represents x. And now I'm left with 2x on the left. Remember that these 4 values represented 11, and these values represented 11 5/10 for these 4. So let's see here. If I took out the circles, that would give me 6 on this side, or excuse me, removing 6 on this side, so that would give me 5. And then if I did the same thing over here, that would give me 5 5/10. Let's go ahead and get rid of a triangle over here. A triangle is 2.5. That gives me 2 5/10 on the left. Take out that triangle, and now I'm down to 2 5/10. And then if I take out the triangle over here, that gets rid of all of my constant. But if I'm eliminating the triangle from here, that takes out 2 5/10. How could I take out 2 5/10? Well, I know this is 3, and I can subtract 2 5/10 from it, equaling just 5/10. So this is what's remaining on the right side. This is what's remaining on the left side. I have 2x is equal to 5/10. B is absolutely correct. Alternatively, we could go back from the beginning when we had the equation 4 times x plus 11 was equal to 2 times x plus 11 5/10. This is getting a little bit ahead, but I'm okay with that. I want to bring it back up. If I want to combine my x's and combine my constants, I can go ahead and use inverse operations. This is a sneak peek to this. In other problems, we have eliminated values from one expression or increased values from one expression, but we've done that equally on both expressions. For instance, I see a variable of 2x here and a variable of 4x here, but they're on opposite sides of the hanger. So think about that hanger right here, and we have these 2 expressions that are being compared. If I take away this 2x from the expression on the right, it's a 0. I can think about that. I should have erased all this before I got started. I can think about all that in the same way as looking over here. If I take away these 2 x's from the expression on the right, I have to maintain balance by eliminating 2 of my expressions, or 2 of my x's on the left. That leaves me with 2x in my blue boxes, and I'm still left with my other 11 in my constants. But over here, I no longer have any x's. I'm just left with 11 and 5/10. Okay. Now let's go ahead and look at the next part of this when we're actually solving, and we're going to work through it. I have on the left side a total of all of my constants is 11, and a total of my constants on the right side is 11 and 5/10. If I take away a triangle and a triangle and a circle and a circle and a circle and a circle, I'm still balanced. At this point, I've taken away 8.5 pounds from both sides. I want to get x, or get this down to just 2x. So I need to eliminate all of this 11, which means I need to subtract 11 from this side as well. So this is completely gone. Subtracting 11 from the expression on the left eliminates it. But in order to maintain the balance, I had to subtract 11 from the right side as well. And what I'm left with on both sides is 2 times x, because the constants are gone, and 11.5 minus 11 is 0 and 5/10. Long way to get around knowing that B is accurate, and B is one of those solutions. Check out C and D and E and see if any of those ones represent a balanced equation. This equation has 2 parts. Don't miss that. What is the weight of a square if a triangle weighs 4 grams? Well, I'll do like what we did before. 4 grams here, 4 here, 4 here, 4 here. And instead of understanding these pieces right now, I don't know what the square weighs, so why not just say it weighs x grams? And now all of a sudden I'm looking at this from the perspective of seeing, well, what am I actually left with here? From the equation side of it, I'm left with 4 increased by 2. I'm not sure why this isn't working well. I'm sorry about that. Increased by 2 of x is equal to 4 plus 4 plus 4, which is 12, plus x. So now how do I work through this? Well, I can go ahead and get rid of one of my 4's on the left, which means I have to get rid of one of my 4's on the right. Getting rid of my value of 4 on the left eliminates the 4, but I have to get rid of that 4 from my like term of 12, and I'm now left with 2 x's on the left, and I'm left with only 8 for my triangles plus my x. Let's go ahead. I don't see any more triangles on the left, so I don't have any more constant value I can eliminate, but I can eliminate one of my x's here, which means I have to eliminate an x from the other side, showing that as subtracting 1x from both expressions. And what that leaves me with here is 1x is equal to 8. We know that x is the weight of the triangle. So let's look at our question. It says, what is the weight of or x is the weight of our square. What is the weight of the square? If the triangle weighs 4 grams, it must be 8 grams. So now complete the statement about how you found your answer. Go ahead and go back and look at that work, and then come down here and answer the question. There is one more square on the which side than the which side, left or the right, left or the right, and 2 more triangles on the side versus the other side. So the square on the left balances or does not balance with 2 triangles on the right. I want you to think about that and complete those statements. Try and hurry through these last couple. Number 4 is a nice little bit of a challenge problem, a little bit of a review problem. Here's what's going on. Andre, there's 2 parts to this one too. Andre came up with this puzzle about his family. He said, I'm 3 years younger than my brother, and I'm 2 years older than my sister. My mom's age is 1 less than 3 times my brother's age, and when you add our ages together, you get 87. What are our ages? Okay, that's kind of cool. So Jada is trying to figure this out, and she says, well, here's an equation for these ages. X plus x plus 3 plus x minus 2 plus 3 times the sum of x and 3 minus 1 is equal to 87. I think one of the most important things that we can ever do for ourselves in a word problem is understand what the variable means first. So thinking about this, what is the logical thing about this puzzle? What is going on here? What is X? Let's read this again. Andre came up with the following puzzle. I am 3 years younger than my brother. I am 2 years older than my sister. My mom's age is 1 less than 3 times my brother's age. And when you add our ages, you get 87. It seems like everything hangs on Andre. So we need to know that X is the beginning with this. I don't know Andre's age, but I do know that Andre is 3 years younger than his brother. So if you take his age plus 3, you get his brother. And then if you take this next part, he says, I'm 2 years older than my sister. So then his sister must be 2 years younger than him. And then you talk about mom. Mom is 1 less, right here, than 3 times my brother's age. Well, we know that X and 3 is B. That's his brother. So this is 3 times his brother's age, 1 less than 3 times his brother's age. By understanding that one variable, we find out that this is Andre as X. Andre is 3 years younger than his brother, so that makes his brother 3 years older. He's 2 years older than his sister, so that makes her minus 2 years younger. And then his mom is here at the end. Now your job with this is, once we recognize what X is, your job is to go ahead and go through and match these up. I know that X is the age of Andre. And then I just need to match up each of these expressions, or each of these terms in the expression. So when we talk about match each term, we're talking about each one of these is a term separate of all the others and different from each other. And each of those terms represent a person or a total quantity. Okay? Once you have those all matched up, simplify the left side of Jada's equation so it has fewer terms. That means that we're taking all of these values right here on the left-hand side, this whole expression, all of these terms, and combining the like terms. But don't forget about the order of operations. We can't really move on with this part right here until that has been simplified. We simplify using the distributive property, understanding that we actually have X plus 3 different times. And so we have 3 of the X, making it 3 times X, plus 3 of the 3's, which is 3 times ours plus 9. And now I can go ahead and start combining the like terms. How many X's do I have? I have 1, 2, 3. 3 more is 6. I have a total of 6 X's. And then I look at my constant values. 3 plus negative 2, which is minus 1, plus 9, there's 8, minus 1, there's 7. Put all of those together in one single expression. There's my total for the X's. There's my total for my constants. And then all of that has to be equal to 87. Double check me on that. Make sure I'm not wrong. And then the last part of this, Andre's age. Tell me what Andre's age is. You'll have to solve for X. Then you're going to have to go back for his brother's age. X plus, remember, Andre's brother's older. Andre's sister's younger. Andre's mom is obviously older. And then make sure once you have these 4 ages, make sure that when you add them together, those 4 ages equal 87. Otherwise, you have the wrong ages. Okay, last problem. Pretty simple on this one, I think. 2 lines are parallel. Complete each or the equation for each line. Write the fractions in the form AB. If you do not use fractions, you will get marked wrong. Plain and simple. The directions state that. We have to follow directions. You cannot add a decimal in here. What we look at for this, complete the equation for each line. We need to find the slope of the first line. Clearly, that first line is going through 0, 0, because over here, there's nothing else out here, which tells us that the y-intercept is 0. We need to find the slope. Pick a couple points. 0, 0. Where does this come up to a nice, another even point? Looks like right there at 5, 4. So I need to find the slope from 0, 0 to 5, 4. I know the lines are parallel. which means that they both have the same slope, which means that this number right here is going to be the exact same number as right here. And this number right here is the y-intercept of the lower line. Hopefully that helps you. Give me a shout out if you need anything. Don't you dare give up, and have a great day.